Welcome to another video on data to decisions. In today's video, we'll be focusing on the box and whisker plot, also called as the box plot in Microsoft Excel. I'm going to be doing this video in four sections. The first section will focus on the concept behind this plot and some of the key components of this plot. The second section will focus on a few formulas that are available in Microsoft Excel that we will use to calculate these key values that are part of the plot that Excel builds. The third section will focus on a few sample plots that I've built. We will go over how to interpret this box plot and what kind of insights such box plots provide to us. Last section will focus on how we can build these charts from scratch in Microsoft Excel. Now let's get started. Now to illustrate the box and whisker plot concept, let's use this example. So I have a list of salaries of 7 employees and I've already sorted them descending order. So the highest salary is at the top and then the lowest salary is at the bottom of the 7 employees. And I'm choosing a very simplified, only 7 data points example, but you can apply this technique to any, a lot of data points in your data set. And that's actually where the benefits are more clearly visible. However, I'm using a very simplified data set because it's easier to explain the concept and the calculations when you have only a few numbers to work with. Now, I've chosen these 7 employees and I've built a chart in Excel using this, and I'm going to explain the key components of the chart. And later in this video, we'll actually build this chart from scratch. There are 5 data labels that you see on the chart, and those are the key components of a box and whisker plot. Compare it to the basic, descriptive statistics that we may be, more used to. We can do when you have 7 salaries, you can do the minimum, you can do the maximum, you can do the average. So those are going to give you a flavor for the numbers that you're dealing with in the data set. However, the box and whisker plot provides a different visualization approach where you can see the entire data set, here's 7 numbers, split into 4 quarters. So what are these 4 quarters? So from the bottom end of this line, which is a whisker, that's why it's called the box and whisker, because there's a box in the middle and then the two extensions on the top and bottom. That's why it's called box and whisker. Now, the bottommost number here, 10,000, represents the minimum value of the data set, and then the top end represents the maximum. So that's 70,000, this is 10,000. So those are the two key points. Next important thing is the box. So the lower edge of the box, it says 25,000. So this is also called as the first quartile or Q1 or a lower quartile. It's basically 25% of the observations are below that value. Okay. And the next important number here is the 40,000, which is the 50th percentile. Because we have split the data set into 4 quarters, right? So now we have reached the midpoint of the 50th percentile. 50% of the observations are below this value, 50% are above this value. And this is also called as the median value for the data set. Then we have the 55,000, which represents the top end of the box. And this is the third quartile or the 75th percentile, or also called as the upper quartile line. And 75% of the observations are below this value. Then finally, as we said, the top end is the maximum value of the data set. So these are the 5 key numbers that make up the box plot. So the box is always, it starts from the first quartile and it goes to the top, which is the third quartile. So you can think of this as 50% of the middle set of values in your data set is represented by the box. Now, let's use the same example and then go through a few formulas. And during the explanation of these formulas, I'll explain a couple of important concepts. One is the outlier concept. The other one is the quartile calculation. And so let's get started. Now, the 5 important numbers that I mentioned in the previous section for a box plot are the minimum, the first quartile, medium, third quartile, and then the maximum. So these points can be calculated using simple Excel formulas. So I can do a minimum function to calculate the minimum salary out of my 7 salaries. The first quartile, you can calculate using a function called quartile.inc, And this function allows you to input a set of salary values here, and then I can say 1 as a parameter to get me the first quartile. And the median has its own function called median of the values in our data set. The third quartile, you might have guessed already, we can use the same function except the parameter can be 3 instead of 1 to get us the third quartile. And then the maximum is a simple max function of all these values. Now, as I said, one of the concepts is the quartile calculation. So how does Excel calculate the first quartile to be 25,000, which is what is plotted on the chart as well. And I'm calculating these in formulas just to understand the concept. But if you want to just create the plot in Excel, Excel will automatically calculate these values and plot it. So we do not have to write any formulas to calculate the chart. However, by looking at this calculation, we can understand a few things better off the box plot. For example, this 25,000. So how did we arrive at that? So remember that the first quartile is basically splitting the middle of the lower half of your data set. Okay, so let's take the data set here. I'm going to select or choose these four values. This is basically the median is 40,000, and then the bottom half of the data set, which is everything below the median. I've selected these four values. Which is the middle value here? Because we have four values, it is in between the second and the third. So between 20,000 and 30,000 is the middle. So between 20 and 30, it's 25. That is how Excel arrives at 25,000 as the first quartile. Now let's understand the third quartile. The median and all the three values above, which is the top of the data set, half of the data set. Where is the middle value here? There are four values, 40,000, 50,000, 60,000, 70,000. The middle is between the 50,000 and 60,000, which is 55,000. And that is why you arrive at 55,000 in the third quartile value. Now, one thing you noticed is that when we try to calculate the quartile, we're actually including the median in both the first quartile calculation as well as the third quartile calculation. This is a setting that is available within Excel where you can turn to include the median or exclude the median. So this setting is available on the chart. If you click on the chart, go to the series, you will see there is an option to change the quartile calculation to inclusive or exclusive. If I do exclusive, now we will again calculate the quartile, but numbers have changed now. So when we calculate the first quartile, this time I am not going to include the median 40,000. I'm only going to include the bottom three values 10,000, 20,000, 30,000, which is the middle value. This is straightforward. It's 20,000. That is the first quartile. And then the top for the third quartile, 50, 60, 70, which is the middle value, 60. So 60, again, please note that we're not doing averages or anything. I've chosen the numbers to be easy to understand, but remember that this is all about the nth observation. It's the middle value is not the average. It is, there are three values, 1, 2, 3, which is in the middle, second value, you take it as it is. Okay, so now that's 60,000. So depending on the setting of whether you want to include the median in the quartile calculation or exclude, the numbers will be a little bit different. And you can also arrive at this using the formulas. When we did the quartile function, we chose the specific function which is inclusive. You can also change this to exclusive by typing in quartile.exe, and now your number will match what Excel is doing on the chart. Same thing for the third quartile. You can do exe, third quartile. Now that number will match your number. So you can arrive at values either way, depending on which setting you choose. I'm going to go back to the inclusive because I think it will be a little bit easy to explain the next point I'm going to make. I'm just going to make it inclusive. And then on the chart, let's change it back to the inclusive setting. Okay, we'll come back. So now we've covered the inclusive versus exclusive setting. The next thing is the outlier. So what is an outlier? So let's say in our data set, the top maximum value is 70,000. What if there was somebody with 110,000? Now, suddenly, Excel will say, oh, that's an outlier. I'm not going to plot it with the blocks plot within the box, including in the box. It'll be a completely separate outlier point. Now, how does Excel know what is an outlier? So there is a theory that if your observation value is greater than the third quartile, which is in this case 55,000, plus 1.5 times the interquartile range, okay, then it's an outlier. So that's the theory. So what we're going to do here is we can calculate that also in Excel. The interquartile range is nothing but how tall is this box? Basically, the top end of the box, which is the third quartile, minus the first quartile. So the distance between the quartiles is the interquartile range, which is 30,000 because 55,500 is the third quartile, 25,000 is the first quartile. So now we get at the interquartile range is 30,000. Now we multiply that by 1.5 to arrive at 45,000. Now the third quartile, which is 55,000 plus this 45,000 is 100,000. Now, let's test this by entering a value which is a little bit greater than 100,000 and which is already there. But let's try, for example, 101,000. That is still an outlier. But let's say 100,000 exactly. And that's not an outlier. So clearly, anything greater, so 100,001 will be an outlier, but 100,000 is not. So now we know why Excel thinks that way because of this formula around interquartile ranges, and then you add it to the third quartile, that becomes your top limit. Similarly, there is a bottom limit. So the first quartile minus 1.5 times the interquartile range, which gives you the bottom limit. And anything below that will be considered as an outlier. In this case, it happens to be negative 20,000 based on the values that I've entered here. We only have 7 values and all that. But in certain scenarios, the negative values could be possible, where if your negative is extremely negative, so let's say, for example, I'm going to put in minus 50,000 as a salary. I know this doesn't make sense in the salary data, but if it is, in your data there is a negative value that is possible, then that could be considered as an outlier on the bottoms end as well. So both sides outliers are possible and they will be automatically detected by Excel in the plot. Now, important thing to note here is when you have these outlier points, what happens to these whiskers? So let me again put another value on the top. So you will see that there are two outliers, one on the top and one on the bottom, but still the whiskers are stopping at 60,000 and at the bottom it is 20,000. The reason is always these whiskers will be actual data points. Now let's take a few examples to understand how we can use the box plot to interpret insights from the data set. For example, I have three side-by-side box plots, the IT department salaries, marketing department, and sales department. Now, I have chosen data in such a way that the scale on the y-axis is the same, so it allows me to compare even better. And so now the IT department, marketing department, sales department salaries are plotted, but there are a few things that we can look at to gain insights from this data sets. First is you can compare the overlap of the range of values. So for example, the minimum value for IT is 10,000, maximum is 60,000. It is the same for marketing as well. So there's a complete overlap when it comes to the range. Sales is almost there. It's slightly below on the lower end, but the top is 60,000. So overall, there's good overlap across these three departments when it comes to the range of values of salaries. However, when you start looking at how they are distributed, they start showing some differences. So, for example, the sizes of the boxes are different, and the length of the whiskers, for example, on the sales, it's much taller on the top end compared to the marketing department. So, what does the size of the box and the length of the whiskers, what do they mean? So, if you have a data set where the values are more concentrated around the median, then you would expect a shorter height of the box. So here, for example, for marketing, the box is very tall, which means that the data is a lot more distributed than concentrated around the median. And then the whiskers, for example, on the sales side, there could be one or a few observations in the top quarter, which is far away from the third quartile. So basically, you have one or two employees with salaries which are much higher on the sales department compared to the rest of the department. And so that is why the whisker is also extending, far more on the top end. Now, this is how you can use to understand one distribution. You can compare across the departments to also see how they are different. The next thing you can use is to see where the median line is and with respect to the first or the third quartiles. So if I'm looking at marketing, this median line is exactly equidistant from the first quartile and the third quartile, which means that it is more of a normal distribution there compared to, let's look at IT. The median is closer to the third quartile. It's further away from the first, but it's closer to the third. So what does it mean? So there are values in the bottom half of your data set which are further away from the median. So you have values below the median, which are far below. So you have very few employees with much lower salaries than the median, which is kind of pushing this box or stretching the box to the bottom. This is called a negative skew. And the opposite is the positive skew, which we see in the sales department, where the median is 12,500, but the third quartile is so far high at 36,000. The first quartile is so close at 10,000. So what does that mean? So you have a few employees in the sales, which is on the top half of your, when you order the employees, the top half, where they are getting a lot higher salaries than other employees in the sales. And that is why they're able to pull the third quartile further up, and this results in a positive skew. Okay, so these are some of the insights you can gain by understanding the box plot. And as your data changes, you can also see how the distribution of your data set has changed over time as well. So now we'll take a look at some examples of charts that we can create in Microsoft Excel next. So here is a sample of the type of charts that we'll be building next. The first one is department-wise employee salaries in 2023, which is on the x-axis, you have the different departments, and then you have those three box plots, one for each department, representing the salaries in a year. Now, if we take the same, and then I'm going to go to the bottom here, and this one is looking at salaries in the departments, but I'm comparing 2023 salaries versus 2024. So there are two box plots for each department, one for 23 and one for 24. So this is one way to build these charts. And then the top right here, this is employee distribution by department. Again, this is very similar to the chart one. However, they are built as different series, so you can actually customize the colors if you would like to show each department in a different color. The same thing at the bottom here. Um, for each year, I can show the three departments, and then for the next year, I can show the same three departments, and I can keep the colors, represent departments. So the difference here between this one and the left, on the bottom left, is here the x-axis represents a department, and then the two series are two different years. Whereas here on the bottom right, the x-axis represents the year, and then each series represents a different department, and we have three series. So these are some different flavors. Again, they will have some similarities when we develop them. We're going to build all these right now from scratch. Let's go. And I'm just going to choose the values here. So there is the department. So in cases where you're able to create this category here as values. And so what does this mean? So these are the employees. There are 7 employees in the IT department. I have their values, but I'm actually putting the department name next to it. And if this is how the data set is for you, then, or you can create this, then it's very simple. Once you have the data set, you can just select them and then go and say insert charts, go to all charts, and then there is a specific one which is specific for box and whisker. Choose it, say OK, and there you have the chart. Now, one thing you will notice is that it kind of included the header, so I'm just going to go ahead here, and you can edit the data that is being fed to the chart. So I can change this to include only these values because I have a header, and then go to the series, and you can give a name to this. So maybe I can say 2023 salaries, or type in your series name, and then the values start from here. So Excel didn't think that as a header, mainly because I have a number in the column C, 2023. So it probably thought it's a numeric value. It's okay, it's not a problem. So now we have created the box plot. And so let's say, for example, to customize this, you can right click and do Format Data Series, and this option opens up. And first, let's do the color. So I can go to Fill, change the color to the color that I want, and then I can also put a border line. So the border line, you can choose and also change the width of the border line if you'd like to see. This gives you a basic chart, which is the box and plot, but I'm going to go back here to the 2023 salary series, and then you can go to this option, series options, and you can, if you don't want the outliers to be included, uncheck the box, and the mean is shown with a cross here. So I'm just going to remove that so it doesn't show up. If you'd like, you can. You can also put a line. Again, I'm not doing that here, but those are the options you have. There is also an option to show the inner points. Okay, when you click on that, all the data observations will be, attempted to be shown on the chart, which again, I'm not sure exactly the use case where there'll be not be too much clutter. So again, I'm just going to ignore that, but that's the setting you have. Now you can also control the width. So as I increase it, notice that the box is going to get narrower, right? So if I do 200, the box is getting narrower. If I do 300, it gets further, and so on. So I'm going to leave it at 200%. That looks okay to me. Now, if you click on the chart, and then you can add data labels. However, again, this is one of those where with too many values on chart, I'm not going to recommend that unless you have only one box plot. But otherwise, generally speaking, I'm just going to avoid putting the labels in, but that option is available if you want to. Okay, then you can add the legend. In this case, I'm not going to do it. We'll do it in the next chart, because there's only one series, so there's no real need to, show the legend. I can just change the chart title instead to say employees salaries in 2023, distribution by department. So that could be my title, and I can customize the formatting um, of my title. And then you will notice that there is a lot of restriction when it comes to formatting within Box and Whisker plot. Remember that we did a long video explaining in depth about waterfall chart, how you can build it from scratch with a lot more functionality than what Excel gives out of the box. Similarly, box plot, I think we can do a lot more with customization if we build everything from scratch, compared to using Excel's out of the box chart that it provides in the list of charts for us to choose from. If you would like me to build do another video explaining how we can build the same chart step by step without using this, but having a lot more control on the formatting, please let me know. For example, legend. I can't move the position of the legend easily, manually move it. I cannot do the formatting of the border of the charts the way I want. I can't turn on and off specific data labels. Either I turn on the labels or not. I cannot say specifically. Unless there is a way that I don't know, but I was not able to uh, see how we can selectively choose labels. Otherwise, it makes it too much clutter. So I end up not using the labels. So we could do a lot more by customizing it ourselves. If you like video on it, please let me know in the comments. Now let's look at the next one. Here we have the same kind of information, but what if I wanted to do this as three different series? So if your data is structured this way, where you have the IT department employees, salaries, marketing, salaries. If you have structured it this way, no problem. Again, select this, go to insert, go to charts, again, choose the same box and whisker. And now this gives the data this way. And once again, let's go and check whether it treated the year also, because I don't want the year to be a series. I just want IT, marketing, and sales. So let's look at IT, and IT values are these values. So that looks right. So I'm just gonna hit OK. And in this case, we don't need the x-axis labels. So I'm going to click on them, x-axis title. I'm just going to remove it. And then you can see that these are three different series. So it automatically gives them in three different colors. You can click on it and then change the color. So for example, I go to IT series and I can go to fill. I can change the color to what I want. And then I can put a border according to what I want. When I go to the next series, I can change the color to a different one, and then I can change the border to a different one. Same thing, last series, I can change it to a different color and the border. So now this is how you can customize each of the three series separately, and you can again remove the mean markers, and you can do this now for each of this series separately. So that's the benefit of going with this approach. You have a little bit more control, and again, you can choose the inclusive versus exclusive calculation for quartile, which is always available to you. Now, this is our plot, the box plot, and I'm just trying to think what other settings did we. So we changed the color. You can again add labels if you'd like. Oh, important thing. I forgot the legend. Without the legend, this chart doesn't make sense at all. So you have to absolutely have the legend if you choose this method, where we have three series. So you have to bring the legend and say which series is what. So now it clearly tells us, IT, marketing, and department. Again, salaries, distribution by department. Right. So let's go to the third type of chart that we can build. So this time we have this one is we have two series and three categories. Okay, IT, marketing, sales, but then we have 2 years of data. So two series and then three categories. So select everything. Let's say I'm just gonna choose year 2023 and year 2024. Let's see how Excel reacts because it might be thinking the column headers hopefully correctly this time. So insert, go again to the same box and whisker because there's only one. You select it and automatically Excel creates. So now we have IT department. We have both years. So this came up correctly. I'm going to add the legend because it is extremely important to have the legend. So in 2023, what was the salary distribution for IT 2024? So you can clearly see that it's plotted correctly this time. Great. And so I can change the colors. I can go to the chart year 2023 series, and then I can change the color, what I would like. And then I can go to 2024 and change the color for that as well. So this is how you can customize it. And then the same thing, you can click on a series, don't show the main markers, don't show the main markers. And you can customize the border color as well, which I didn't do. And then one thing I forgot to mention is you can change the grid lines, right click, and if you are finding it difficult, like I did, to format the grid lines, there's also another way to do it. So you can go here to the drop down. That is the way you can easily select. And now I can do solid line, make the line less visible. And so here is our third chart that we can build. Again, adding labels adds clutter, so I'm not going to focus on this, but this still gives you good indication of the plots themselves and the distribution of the data without the labels. But if you want to, you can add the labels if your data set allows without adding a lot of clutter. Then we go to the last type of chart, which is where if your data is structured this way, where you have the year, which is the series here, which changes into a category, and then the three departments are three different series. And so same thing, let's go to insert, all charts, box and whisker. What has Excel done is right click, select data, you will see that it has added year as a series. I don't want to add year as a series. The reason why it did that is probably because numbers in this column S, if it was text, it would have handled it differently. When it sees a number, it thinks it's a series, but it is not. It is a category. So I'm going to remove this, and instead we're going to use this as our labels. Then that gets us to what we want. So x-axis shows the 2 years, and then there are three series for three departments with three different colors. So I can go into change the fill to another color, solid line, change the border, same thing. I'm going to go to the next department, change it, change it. The last one, I think we didn't do this color, so let's do that. There we go. All the three done. And then we can remove the mean marker, and you can do that from here, series option, change it, and then for the blue one, I'll change it. Okay. So now, once again, it is important when you have multiple series to add the legend. So I'm going to add the legend. And earlier I said that, the legend, there's some restriction. So yes, you can change it. I'm going to leave it as top, which is where I usually do. And then I would usually like to move it to the top right, but in this case, I cannot manually move it. If I choose top, I don't even have that option. No, I think there is a top right option, but it moves it to here. And when I try to manually move it around, I am not able to. So that's kind of the restriction in formatting. And again, we can do the title. We can remove the grid lines. So let's see how we can go here to the grid lines, fill, solid line, make it less visible. So all that standard formatting things we can do from here. So one last time, these are the different chart specific settings. Inner points generally don't recommend because it'll create a lot of values on the chart. Mean markers, again, unless you want to see the mean or the average, otherwise remove it. And then the gap width you can control to control the narrowness of your box. And then the quartile calculation, you can change between inclusive and exclusive. Okay, so that's everything. So we have now created those four types of charts. Again, those are not technically four different types, but depending on how your data is structured, you can choose one of these options. Multiple series, single series, whether your data is structured, vertically stacked or horizontally laid out, all those combinations, you know now how to create the box plots. If I've misrepresented anything, if you have any suggestions or corrections, please let me know in the comment section. I look forward to learning from you. And thank you so much for watching, and I will see you soon in the next one.